but yeah. 667, beautiful arrangement 2. Given two integers n and k, you need to construct a list which contains n different positive integers ranging from 1 to n and obeys the following requirement. Suppose this list is a sub 1 to a sub n, then the list, a lot of different absolute numbers, has exactly k distinct integers. If there are multiple n's, point to any of them. Okay, what is n? Okay, n is too big for it to be, whatchamacallit. So you can't do just like calculate every permutation because n is 10 to the 4, which is 10,000. I actually made a mistake the other day, but I thought 10 to the 4th was 1,000 and ended up using an algorithm that was too slow, but cool. Maybe you could do some funky stuff. Maybe there's like a greedy way of doing it. No, that's not true. I don't know. Okay. Oh, K must be smaller than. Okay, I mean that's. Thanks for the heads up, PB action. For a second, I read bacon. Maybe I'm a little hungry today. But yeah, so that's kind of helpful. But I mean, it just means that. I mean, if K was bigger than N, that's just trivially not true. I think. It seems like there's always an answer because it doesn't. So there's always an answer. So there's some kind of heuristic, I guess. Okay, I think what I would think about for this problem is, well, let's start with literally a sorted list, and that's k equals 1, right? And k equals 2, you just kind of sort one of them, or like, not sort, you shuffle one of them. But what does k equals, oh, I guess k can be equals 3, but then we could, at least not for n equals 4, but let's play around a little bit. Let's say we have n equals 4. So this is, I guess this is akin to what I do on a whiteboard because I'm just working out this problem. A lot of times, at least on the stream, I don't do it necessarily because a lot of them are just like, hey, I'm going to search or whatever, which I talk about. But and if I was an interview, I would definitely still draw pictures and stuff. But that's not whatever. But so this is equal to k equals 1. Let's say we have one shuffle, right? So then, because these two are still 1 and this is still 1, so this is k equals 2. How do we get 3? Do we just move this? So now this is 1, 2, and 3. Is that it? Is that why people hate this problem? Okay. Let's try another one. Just if that's the case, then I mean, I guess it is as easy as it sounds. But so I think the proof-ish though is that no, maybe not, because I think maybe I just got lucky because of this one. I think you might have to move another number, like maybe I don't know. Let me see with this one. What happens if you move 5, 5, 3, 4? Because then you create 2 extra ones here. 3 and 2. So this is, I mean, this is 3, but is this the, this is not the way to k equals 4, right? Because I don't think so, right? Because all this is 1, 2, and then these are the same. So you would need another invertedness, which is 4, 3, right? Yeah. Did I miss that? Oh. Oh, it's absolute numbers though. Well, that's how I read it. So the negative 1 is yeah. Okay. Oh, okay. So it's not as obvious as just moving the last number, which would be a little sad. But there's some there's some like like it's almost like to like it's almost like a SNCC, I think, because and I think that kind of makes sense in that like uh oh because well I mean you still have to move the last number, but that's not sufficient because here the k is you go to 1, 2, and then 3, and then, so this is has a k3, right? So you have to move one more number to make it k equals 4. And I think I would kind of think about it as a SNCC where you have a chain, and then almost like interleave the last like almost like a roundabout. I don't know if I'm drawing this right, backwards to kind of like in between to create one more, right? I don't know if I'm saying that right either, but because for each number at the previous end that you interleave, you create one or two additional numbers. Does that kind of make sense? I think that's probably because, and then the rest you could just treat as default because if you don't move any number, it's always going to be just the delta is always going to be 1. So there's some, I think that's roughly right. I don't know how to, well, I mean, I still have to figure out how to like represent this. Algorithmically, it seems like a little weird though, but like people complain about these problems not really related to programming, and this is definitely one of those that even was, or even not really related to comp sci per se, but I think that's roughly right. I think. Interesting thing is, there's some interesting things around this, but because because for k equals 2, you want the first difference to be 2, right? And for k equals 3, you want the first difference to be 3. I mean, you could do it other ways, but that's the way that I'm doing it. And then first is 4, and then you just kind of get the, you do 4, 3, and then 2. Okay, maybe that's how I would do it. Okay, but how do I formalize it? Okay. I mean, essentially, it's just like you have to do some clever-ish, and clever is the question mark profit clever way of kind of winding it. But I think this is just off, and I having like clever way to pointing stuff. Okay. I'm just gonna. This is the part where I start hacking a little bit. I think in the interview maybe I would talk about it a little bit more. But I mean that's enough for me to kind of get started on. Okay. At least that's the way it is that. Yeah. I think another way to look about it is for k is equal to whatever, you only need the last k digits to be in a shuffled way. Seems like that part is consistent. So maybe I'll just do that. So that means for the first n minus k numbers, I don't need to move. Okay. For what's the k minus 1 I said? Still thinking in other languages sometimes. And then and then the first number from the back shows up. So okay, I'm just gonna name these. So the front, you want the front to be the k. No, n minus k. No, you want the front to be n. That's the first number you see. Wait, no. I mean, you do, but that's the back, maybe. I'm thinking of it as kind of like a snake, and then kind of, I don't know. I don't know if that's a good way of thinking about it, but that's how I'm doing it. I mean, this is just K, because you need to sort the last K to N. Yeah. And then, well, is less than, was it N? Yeah. We add the back. I have to check some bounds here, but maybe something like that. Could be off by one. Let's see. Oh, well, that's actually closer than expected, but this should be +1. Well, I guess I could change the X range, but yeah. Okay. I should try the more trivial cases. Oh man. Okay, let me just type more then. I guess those are the 2, but 4, 3, 5, 4, 5, 3. Okay. Yeah, they have different answers, but we could actually check ours manually, right? In that, like, 5, 4 maybe is wrong, actually. Maybe I calculated the other way. Oh. No, this should be N. Why did I do the N? Something like that, actually. What am I doing? Okay, let me step back for a second. I'm just like throwing stuff at the wall to see what stick. All right. But I definitely like messed up some of the constants that I said I was doing it in, because I want the first 4. Oh, sorry, I want the last 4 to be jumbled. So that means I should only out N minus K. Why did I put K1 there? Maybe I just got confused something. And this shouldn't be right. It should just, the first character should be right. Okay. And then now, this is maybe wrong now. Not maybe, but certainly. The font is N minus K. Yeah. I think I just mixed them up, maybe, in my head. Okay, and I have to add a +1 somewhere, maybe. And the good thing about this problem is that you could test your answers, even though there are multiple answers. So the system output is not going to be necessarily whatever. But the good thing is you could check it manually, right? Because you could do 1, 2, and then 1, 2, 3, and 4 for 1. So that should be right. Also scary that that's not right. Scary that it passed a lot of the test cases, right? So that's why we kind of tried to do more. Okay, we tested one case. What was the last one? 4, 2, 1. Even number. Maybe I'm off by 1. That's what I have. I have the 4, 2 answer. Oh no, maybe not. Sorry, that's. I mean, there's still 2 is 1 and 2, which is between 2 and 4. But their answers. No, I guess they matched the 2 twice. Okay. Yeah, let me try the one element case, just because 1, I guess 0. I mean, that's the only possible thing. Oh, I guess technically that's not possible. N has to be 2. but yeah, let's try that anyway. Yeah, okay. Okay, let me just submit it then. Okay. I mean, this is O of n, so hopefully that's okay. Okay, cool. Yay. Um, yeah, this is O of n because we hit each number once and append it, so that makes it even more clearer. I could use less memory, I guess. Don't use a list. I don't even construct anything. And this is O of n memory only because we returned the array. So that you can't do any faster than that because that's literally the size of the output. But I don't really, I don't know if I have any advice on solving this problem other than kind of, because I mean, the way I solve this, how I would solve it, and that's how, I try to solve it the quick as I can. So I'm not trying to like, slow roll it or anything. And you see me just kind of like, do some examples on the whiteboard, if you will, and kind of figure it out a little bit. I don't know how to I don't know how to teach that, right? Like I'm just kind of like doing things manually and then kind of guess at an answer and hope that works a little bit. And I did that a little bit, a couple of times in some way. And then like I guess, oh, maybe you just have to move the last number. And then it turns out it's not the case when you break it out to n equals 5. And then I tried this again, and then I came to this intuition a little bit where if you move one number from the back to the front, you add two difference, and so forth. And that's kind of how I did it, but that's like almost like yeah, but that's like me justifying what I did like backwards. Like it was not like I didn't have anything that's proof level like mathematically. It's just like an intuition. I'm like, okay, I could see how that works. So to be honest, I don't know. Maybe we look at the discussion forum for this problem. Maybe they have a better way to kind of explain this problem, or at least like I think explanation is not as, for me though. Explanation is not as interesting as how to arrive at that explanation, and I think that's the problem that like people don't discuss the thought process enough, which is what I try to do. So what you see here is what I would have tried to do during the interview, right? Roughly, but yeah, similar to. I think that's a good point by Poster Rat. I think, especially with a multiple answer problem, a lot of times, and I've done this before, but not in this one, where yeah, you could write your own tester for this problem, right? Like, I mean, in fact, you could even like before you submit it. If not, then you like fail an assertion test or something like that, and like really so that you really know why that is, and then you could like, and that's a cool thing, and actually goes back to what we said about previous problems about writing tests, and actually you could write because you know what the right answer is given an random input, and you can actually generate random inputs and then have the tester and then kind of do it that way, right? And maybe you don't even have to do you don't even need random because n and k is you could one for really big numbers because they only go to 10,000, right? So you could test a lot of these things. So I think that would be great. But yeah, but otherwise it's yeah. I mean, I was going to answer PB Action's comment about identifying the correct output. I think essentially Poster Rat answered it, which is that we would write tests in a very functional way, and you could and the space is not that big. You could actually even try exhaustively, or 10 to the fourth square, which is not small, but small enough that in theory you could like, especially since you could do it offline, you could test all possibilities to make sure that this is right for all of them, right? But yeah, and this is all of n, so it's not, well, I mean, that was still one. If you do it that way, it'll take a long time, but because you can do it offline, it only takes a couple of minutes, but yeah. Oh, if a tester tells you it's wrong, but you don't know what the correctness, yeah, I mean, I don't have a great answer for you, to be honest, necessarily. I think I would just play around with like, okay, like if I have like a lot of it, and this is hand wavy, and I understand that it's not what my intention is, but I think some of it is like depending on how I'm wrong, like there may be some intuition, like, and you see it like I've done it other problems where I'm like, oh no, this is clearly wrong, so I have to kind of scrap this whole thing, which I've done it before, even today. Um, but some of it, I'm like, oh, like obviously if it's off by one, I'm like, okay, like maybe I would write and like we talk about writing a like a function to test the correct answer. Maybe I could, instead of like a Boolean test, like you expect five numbers to be different, but you only got four numbers to be different. Then you investigate why. Like, why am I missing one distinct positive integer difference or whatever, right? Maybe I could do something like that. Like, is it off by one? In this kind of problem, I think, or this not this kind of problem, but this particular problem, I feel like the only way I could have been wrong is off by one. The way I've been doing it, because some of it is intuition, some of that I kind of allude to with every time you move a number from the back to the middle, you create an additional two difference, and so you can only be off by one or two, and you move a number from the back to the second to last number, then you create a delta of one, right? So those are like your components of getting like twos and then you kind of, if you want to call it that, sum it all up to get k, yeah, k. So that's how I would kind of, and some of that is like hindsight 2020 thing. So I didn't describe it like this when I was solving it, but that's how I saw it after I kind of look into it, because here you only just create one extra k, and then here or any other middle ones earlier, then you get k plus, or you get two new k's, right? So I think that's how, I think it's very problem specific. So definitely, if it comes up later, I hope to kind of answer your question again. And I think a lot of it's just intuition, which is also like experience over time kind of thing. It's like, oh, like maybe I've seen this similar problem from this, from some other points of my practice, and maybe I could, use what I learned from that problem to do it. And that's something that it actually comes up a lot more when I do dynamic programming, to be honest, because a lot of times in dynamic programming, you know what the right answer is, but you don't know how to get that right answer. And it could be something as trivial as off by one somewhere in indexing, but your answer is very drastically different. And when it comes up, maybe we could talk more about it. But you actually, and if we go for some of my longer YouTube videos near the end, and the tag dynamic programming, I think that comes up a lot, where like I'm trying different things and I'm trying to like figure out how to rephrase the problem in different ways, and especially maybe not this particular problem, but like specific to dynamic programming, where I do it recursively with memorization. Then like, well, the sub problems we could manually figure out, or write a tester, or do it, or even write like code that does it, the brute force way, and get the right answer for the brute force for smaller ends or something like that. And then kind of like, well, why is that wrong for that small example, right? I think in general, I would try to figure out the easiest, not easiest, but simplest input that makes that my code is wrong for, and then try to really understand that and solve that. I think that also, in general, and this goes back a little bit to what we're talking about, like having, and I don't do a good job. I don't do a good job on this on stream and especially on Leetcode, because Leetcode doesn't do this easily. And but what I try to do is, like I don't throw away test cases, right? So I could incrementally keep on making more and more things right, and if I fix something for one test case but breaks a previous test case, then I'm like, okay, I go back and think about why that is the case and stuff like that. I mean, I don't know. I mean, this is very abstract and hand wavy, but it definitely depends on the problem, I think. So I don't know if I have a better answer to that than that. But I hope that answered your question, though. But I think the intuition, I think now after solving this problem, is the way I would describe it, is that you have a number in the end, k, and you could either move this, and you can move this in a number of places, right? You can move this either anywhere in the first, basically any number except for the number that's right before it. You get two new k's. Like here, you get two new k's, and that's why you got k equals to 3. and you always have k is equal to 1 as your base. And then here, you move a number from the end to 1 right before the number in the end, and you get only k plus 1, right? So that's, and then you kind of, and that's kind of the recursive E way of thinking about it, maybe. And you can maybe even move, I mean, I think the different solutions kind of goes, if you think about recursively on the last digits, maybe you could think about like moving 3 up or something like that to generate. But that's kind of how I would maybe describe it. Sorry, I need some liquid. I talk a lot on this particular instant, but yeah. Excuse me. But yeah, yeah. You see my thought process as I'm trying to get through this problem. I don't think I have anything clever about it, but I think that's what I was trying to do with actually like visualizing this out here. Is kind of like see if I see any patterns, right? And I don't know going in that I will see a pattern, because with dynamic programming especially, like often I don't necessarily see an obvious pattern. So yeah, that's all I kind of have for this problem. Oh yeah, well, that's all I have about describing this problem. But let's do a quick postmortem. I don't think I could have solved this any quicker or better. I don't know how much time I spent here. I did talk a little bit, but like roughly half an hour, which is okay, I think. Especially a lot of that half hour is me rambling. But let's see. Yeah, in terms of an interview, I think. I mean, I personally don't like this as an interview question. I wouldn't ask it because it's a little too mathy, and not like. I mean, I think I excuse a little bit on computational or computer science related math, which like algorithm stuff I'm okay, even though maybe some stuff is a little hard, but like I can understand why. Or like hard as in like more theory oriented. At least I understand it and I could accept it. But like this is just like there's two. I mean, it's not that much related to math per se, but it's a lot. It's still a little weird mathy stuff. Maybe someone could convince me otherwise, because maybe there's some stuff with swaps and stuff like that that you could justify it. But I personally wouldn't, because I think like I don't know. I personally try to make it like something that like I would learn something about your both problem solving and also coding. I think coding, once you get the problem solving or the algorithm or heuristic or whatever, like there's nothing interesting about the code that like makes me like. I mean, you could definitely do this very unclean, very like bad code and still get it right. But for the most part, and in those cases, like I know that I'll try to be understanding, especially if I was forced to ask you this problem, say, I'll be like, okay, like, people have enough to worry about initially, and if they could get it right, even if it's kind of bad code, I understand it, and I would follow up, be like, okay, now that we've solved this problem, how would you clean up your code? And then, we walk through the ways they could clean up their code, and that's fine, right? But I wouldn't necessarily learn that much about it. So I would ask, I mean, that's not my type of problem. I think, would I expect to see this on a problem? On an interview, I mean, this problem in an interview? Probably not like normally, but like, I don't know. These type of problems are like such a like rolling of a die, right? Like if it, like the difference between if I have a candidate who solves it in 5 minutes, say, versus a candidate who solves it in, I don't know, half an hour, right? Does that mean the candidate who solved in half an hour is necessarily less competent than the candidate that solved in 5 minutes? I don't think I could convince myself of that. So like, I mean, like at the end of the day, any problem can be asked because you have bad interviewers in general. But I think that's something that I would think about. And like, I'm okay. I don't know. I hope I gave you insight on this one. I mean, I don't know if I would expect to see this. I mean, it's up here. Some people may like this problem and do it, but like I wouldn't necessarily expect to see this per se. But yeah. Yeah, you definitely learn a bit more about like how they go about debugging, for example, and all the things that we talked about, um, and how to like approach the problem. Um, but I feel like even in that world, right, like I feel like there are better problems to do that versus like this abstract problem. And I think one thing I would say during my experience of interviewing people is that like because this is a very like weird-ish problem, um, like one is you'll get a, you get a good amount of candidates who will just sit there and like think about it, like, and you have to like poke them to kind of ask them what they're thinking about. And the thing is that it's very binary, right? I think I like to ask problems where like they could work and make progress, where this is like, okay, I'm gonna guess the solution. Is this right? If it's right, yay, I move on. If it's wrong, okay, then let me see if I could guess another solution. No, can't guess another solution. No. So I think like for me, that doesn't, like, I mean, it's nice to kind of see how they grind and what happen. Like, I guess it's nice to see what happens when a candidate like struggles, but like that's not what I necessarily interview for per se. That's maybe more of a behavioral thing anyway. But so yeah. Anyway, that's my thoughts about this problem. I think.